Hi everyone, welcome to part 3 of my character creation tutorial. If you haven't watched the previous parts, please do so, because we'll continue right where we left off. Last time we covered the body part scene for our character creation screen. It is used to change the graphic and color of a single body part. Let's see how we can implement the rest of said character creation screen. As explained last time, we have custom signals for the body part selection scenes, namely image changed and color changed. Just like before, we now need to assign these signals to the character creation root node. We don't need to pass any extra arguments as we use different functions for each body part per signal. But you could just as well use the same function for all parts with an extra argument if you want. Also, don't forget to assign the pressed signal of our accept button to the character creation root node with its own function. Now let's go and take a look at the character creation script. Because of the signal connections via the UI, we have a bunch of functions in the script already. For each body part, there is a function for changing color and for changing the sprite image. Inside these many functions, we either need to call change texture of body part or change color of body part, and pass the appropriate arguments depending on the signal function calling the inner function. So next thing we need to know is what change texture of body part and change color of body part actually do. Luckily, these functions aren't all that difficult. Change color of body part expects the node path to the sprite node of the body part as a parameter, along with an index for which color to override and the new color value. So basically what we did in the first video via the Godot editor, we can now do via script in-game thanks to this function. And because this function is wrapped around a signal function, we can also call it via the in-game UI, get all necessary arguments and have a streamlined way of applying the changes. First, we get the actual node instance via the node path argument with getNode. As the node path argument is just a variable containing a string, getNode uses that string to find the node in the actual game's hierarchy and returns the node to us. Thanks to color index, we know whether to change the red, green or blue color of the sprite in the shader. Match works like multiple if statements, which would look like this. As you can see, match is a much shorter way of writing a condition with multiple exclusive branches of execution. After match, you name the variable of which we want to know the value. In the lines after that, you first write the value followed by a colon, for which the commands after the colon should be called. Of course, you can also do multi-line commands, just like with normal if statements. Match is really versatile. You can also check for strings and other values, not just numbers. But if you want to have a default case that is used when no other match was found, write an underscore as the value like so. Anyway, we use the different matches to either change the red, green or blue color by calling the material of the node and use its function setShaderParam. In there, we pass the name of the parameter we want to change and its new value. Change texture of body part is even simpler. Again, we get the actual node of the body part to change and assign a new texture to node.texture. We get that new texture by using the load function, which loads resources of your game. All you need for that is a string for the file path of said resource. A file path in Godot starts with res://. This is a Godot internal shorthand to show that the file is in the project folder of Godot. There are other shorthands as well, but we'll get to those some other time. Anyway, we use the str function to create a new string based on the value of our resource path and an index argument plus the file ending .png. By concatenating different values to a single file path like this, we can use many different files for a single body part to add variation to our character creation. Each file for a specific body part will have the same name, except for a single number. So if I have 3 different files for shoes, I use the convention feet0.png, feet1.png, and feet2.png. Now we can cycle through the different variations of the body part just by increasing and decreasing the index value. There are 2 more functions in the script: getBodyPartData and the signal function for when the accept button is pressed. The first one is used in the second to pass the customization data of the character into the next level. Again, we get the actual node of said body part with the node path string argument. Then we create a small array called colors and append the different color values for overwriting red, green and blue to it. After that, we create a dictionary. The difference between a dictionary and an array is in their use case. An array is just a number of elements you can access by knowing the order of those elements in said array. So if you want the first element, you write array name open bracket 0 close bracket, because arrays start with the 0 element. Dictionaries are used if you want to access elements not so much by order, but more often by name. Our body part data has 2 different elements. One is the index of our sprite to use, the other is a container for the different color values to pass to the shader. It makes more sense to access these different elements via a recognizable name instead of a number. Accessing the index of the sprite by writing result open bracket index close bracket is easier to remember than using something like result open bracket 0 close bracket. Hence why we use a dictionary. So yeah, we save both the index and the color array in the result dictionary and can access them later by passing the string index or colors respectively to result. Now we need to return the dictionary result. Don't forget, if you have a function returning a value, the type behind the arrow of the function header needs to be the same as the return value. So in this case, instead of void, we need to write dictionary here. Of course, you can let Godot figure out the return type itself by not using the arrow syntax in the function head in the first place. As you can see, my convention for that is to leave auto-generated functions as they were made by the editor, while my own functions strictly define the return type. Now let's take a look at onAcceptButtonPressed, which is an auto-generated signal function. Instead of just pass, we have added a lot of code here. First, we get the name of the player character by accessing the text property of the lineEdit node. As long as that text isn't an empty string, we consider the whole character creation valid. We save the player name in a variable called global.playerName. I'll explain this in just a bit. Then we get the data for the different body part customizations with getBodyPartData and the name of the body part scene node as a string argument. These values are again saved in variables called global.something. At last, we change the scene by calling getTree.changeScene with the string argument to the new scene file. In this case, our level scene from previous tutorials. Now to the last part of the tutorial. How do we get the data from our character creation screen into the player character of our level scene? After all, when we call change scene, all the data of our nodes gets deleted. This is where the globals part of the code comes in. There are different ways of making data persistent between scenes. One is to save all the persistent data in the root node, and instead of calling change scene, create the new scene as a child node. That way, at least the data of the root node is always available. I have used that method in other projects and it works well. However, there's also another solution which is much simpler to implement and manage, therefore I'll cover that one here. Godot has a feature called singletons. If you have any programming experience, you might roll your eyes, but don't worry. Godot singletons are different from your typical singletons in most programming languages. This takes a bit of explanation. In your scene view, the root node is not the actual root node in your application. Instead, the root node of the application is unnamed and invisible. You can only access it via the function getRoot. Godot singletons are a way of assigning a permanent child node to that true root node, so that it persists even when you call change scene. So unlike singletons from programming languages, you aren't making a class you can only use one instance of in your codebase. Instead, it creates a node that exists from the start of the application until shutdown. So how do we make a singleton node? Just go to Project Settings Autoload, select a scene in Path, and choose a good name for the node. Then click Add. In the list below, you can then choose whether the node is a singleton and in what order multiple nodes of the list should be created. If singleton is selected, we don't need to access the node manually via the getNode function. Instead, we can access that node directly by its name. Let's talk specifics. I made a scene called global, which consists of a single node with the global script attached. That script contains variables for everything we want to save from the character creation screen. These variables are player name, which is a string, as well as the hair, head, upper body, lower body, and feet data as dictionaries. In set dictionaries, we save both the color and the graphic index, as seen in the onAcceptButtonPressed function. We can access this scene's data by using its name global in other scripts. Hence why we save the character data of our creation screen in globals.something variables. Now that we have the data permanently saved, we can access the data in the player script inside the ready function. So as soon as we call change scene, the player subscene gets instantiated as a node, and this ready function is called, which then uses the data from the global node to change the player character's appearance. And with that, we are done. Wait, no, I actually forgot something easy to miss. Imagine being in the character creation screen, looking at the initial character preview and deciding that that's the character you want to play as. Alright, just type a name, click on the button and you are ready to go, right? No. If you do that, the player character will just be completely black. But why? Because we never synced the values of our body part selection UI objects with the values of our character preview. So if the preview starts out with blue hair, for example, the color picker for the hair color will be initialized with black. When we click on accept, that black color from the color picker is used instead of the blue hair color from the preview. So only if we change the initial values in our UI element, we can sync up the preview with the UI element to avoid this bug. Here's the straightforward solution. First, we need to add another function to the body part selection script called assign values. In there, we pass a new value for the index and a new value for the color of each color picker. Then we simply assign these values to the proper variables in our script and update the label showing the value of the index. With that helper function, we can go back to characterCreation.gd and create the ready function. This function will get called automatically when the node using the script gets instantiated. So make sure, just like in the player script, that it has an underscore at the beginning. Otherwise, it won't work as intended. In the ready function of characterCreation.gd, we call the assign preview to body part function for each body part. We need 3 arguments for it. The node path to the proper node in the preview as a string, the node path to the proper body part selection node, again as a string, and the resource path prefix that we also used in change texture of body part. First, we get the preview node with getNode and the preview node path. Then we figure out the index of our texture in our preview. Remember, the body part selection node saves only an index, while the preview node only cares for the path to the texture file. Due to our convention, it's easy to make the conversion from a texture file to an index number. We take the whole resource path and replace everything up to the index number in it with nothing, basically creating a new string only containing number.png. In that string we replace again, this time .png, effectively keeping the number value as a string. Now we turn that string into an integer by calling int on it and assign that value to the index variable. All of this happens in this one line of code. In theory, getting the colors and saving them in the red, green and blue variables is much simpler. We access the material of this body parts preview node and call getShaderParam with the proper name. Either replace red, replace green or replace blue. Then we get the body part selection node and call assign values with index, red, green and blue. Now I did say in theory for a good reason. There seems to be a bug in the Godot editor, which is difficult to explain. The colors of the shader parameters in the material start out as black, right? So getShaderParam should return the color black if you never changed the parameters manually, right? Well, in my case, for some reason, the application crashed because getShaderParam returned a nil value. Nil is basically a shorthand for invalid or unknown value. But here's the thing. The program works as intended if you go to each body parts preview and manually change the color for each shader parameter in the editor. You can even use black again. Just clicking on the color and then clicking somewhere on the color ramp fixes that bug completely. You just have to do it once for each color of each body part. You don't even have to redo it the next time you start up the program. To me, that seems like a very weird bug I can only explain by putting the blame on Godot itself. Again, I didn't have to rewrite any part of my code to fix it permanently. I'll tell you this here not only for this tutorial, but maybe you encounter similar problems when writing your own shader code. Now you know there's an easy fix to that. And with that, When starting the game, the color pickers and indices of the body part selection nodes will have the same values as our initial character preview. And with that, we are done for real now. We've covered many of Godot's features. If there's anything you didn't understand, feel free to write a comment. And if you like my videos, consider subscribing and/or take a look at my itch.io page. Link is in the description. Thank you for watching, and until next time, bye bye.